Intro. Why is the sky blue? Have you ever looked up at the sky and wondered why it's blue? It's a question that has intrigued people for centuries. The answer lies in the way light interacts with our atmosphere. Join me as we unlock this secret and many more, exploring the wonders of advanced technologies that shape our world. Section 1. Scattering light. Sunlight, which appears white, is actually a mixture of all the colors of the rainbow. When sunlight enters the Earth's atmosphere, it collides with tiny air molecules. This causes the light to scatter in all directions. Blue light, with its shorter wavelength, scatters more than other colors. That's why we see a blue sky most of the time. At sunset, the sunlight has to travel through more of the atmosphere to reach our eyes. This means more of the blue light is scattered away, leaving behind the longer wavelengths of orange and red. That's why sunsets are so colorful. Section 2. Colors of the rainbow. We've all seen a rainbow after a rainstorm. Rainbows are formed when sunlight is refracted or bent by water droplets in the air. Each color of light is bent at a slightly different angle, separating the white sunlight into its component colors. This separation of colors is called dispersion. It's the same principle that makes a prism create a spectrum of colors from white light. The colors of the rainbow always appear in the same order: red, orange, yellow, green, blue, indigo, and violet. Section 3. Exploring the electromagnetic spectrum. Visible light, the light we see with our eyes, is just a tiny part of the electromagnetic spectrum. The electromagnetic spectrum includes a wide range of waves, from very long radio waves to very short gamma rays. Each type of wave has a different wavelength and frequency. Radio waves are used for communication, while microwaves are used for cooking and in radar systems. Infrared radiation is heat, and we experience it as warmth from the sun or a fire. Ultraviolet radiation is what causes sunburns. X-rays are used in medical imaging, and gamma rays are the most energetic form of electromagnetic radiation. We can't see most of the electromagnetic spectrum with our eyes, but we can detect it using special instruments. For example, radio telescopes detect radio waves from distant galaxies, and infrared cameras can see heat radiating from objects. By studying the different parts of the electromagnetic spectrum, we can learn a great deal about the universe. We can study the composition of stars, the structure of galaxies, and even the origins of the universe itself. Smartphones have become an indispensable part of our lives. But have you ever wondered how these pocket-sized devices can do so much? At the heart of every smartphone is a tiny microchip, a marvel of modern technology. This microchip contains billions of transistors, tiny electronic switches that control the flow of electricity. These transistors work together to process information, run applications, and connect to the internet. The smartphone's operating system acts like a conductor, coordinating all these functions. Microchips are made using a process called photolithography. This involves projecting patterns of light onto a silicon wafer, which is then etched to create the intricate circuits of the chip. The process is incredibly precise, allowing for the creation of billions of transistors on a single chip. The development of microchips has revolutionized our world, enabling the creation of ever smaller and more powerful electronic devices. From smartphones to laptops to cars, microchips are now an integral part of our daily lives. The smartphone's touchscreen is another technological marvel. It's made of multiple layers of glass and plastic, with a grid of electrodes embedded within. When you touch the screen, your finger alters the electrical field, which is detected by the electrodes. This information is then sent to the processor, which determines the location of your touch. The processor then sends signals to the display to update the image accordingly. The display itself is made of pixels, tiny dots that can be lit up in different colors to create the image we see. GPS, or Global Positioning System, is a network of satellites that orbit the Earth. These satellites constantly transmit signals that contain information about their location and the current time. Your smartphone's GPS receiver picks up these signals and uses them to calculate your location. By comparing the time it takes for the signals to arrive from different satellites, your phone can determine its distance from each satellite. With this information, It can triangulate your position on Earth with remarkable accuracy. The internet is a vast network of computers that are connected to each other. It allows us to share information, communicate with each other, and access a wealth of knowledge from anywhere in the world. Data is transmitted over the internet in packets, small chunks of information that are routed from one computer to another. Each packet contains the address of the destination computer, ensuring that it reaches its intended recipient. The internet has revolutionized the way we live, work, and interact with the world. From the blue sky above us to the smartphones in our pockets, the world is full of wonders waiting to be explored. By understanding the principles behind these advanced technologies, we can appreciate the ingenuity and creativity that have shaped our modern world. So, keep asking questions, keep exploring, and never stop unlocking the secrets that surround us.